This is lecture 11, example 1. We were talking about registered files in memory in this set of lectures. So these are essentially a couple problems that access memory. Not a big deal. So I'm trying something new here with working with PowerPoint. We'll see how that goes. So essentially this is a problem that essentially it's going to read something from memory. It's going to read bytes from memory, and it's going to store those as words. So it's going to read unsigned bytes, and it's going to from some address, and it's going to store them at some other address as words. So it's going to read in a byte, store 4 bytes. So it's unsigned bytes, starts at x10, and then I'm going to store it at x20. How many that I'm going to do is going to be the number in the x11 register. So what's being passed to this function is a value in x10, which is the address of the bytes, a value in x20, which is the address of where I want to store the associated words, and the number of times I want to do that is written in 11. So the first thing I want to do here is draw a flowchart, and then we're going to skip over to the actually typing this out. I think that worked better than me trying to do it by hand. I think it was quicker. Let's do this. So essentially what I want to do is, I don't know what you want to call this. I'll just call it transnum. Okay, so this problem does want me to save context and restore it because it doesn't want me to permanently change any registers. So this is save context, and then maybe do some initialization, maybe, I don't know. Let's see what I need to do in this. And then lastly, this could be the fact that x11 is being sent the data. That x11 has the number of times I need to do this. That could be 0, so I'm going to model this as a while loop. And I'm just going to say count equals 0. I'll say no. When the count's not equal to 0, that means I'll say I'll get some data, store data. Once I store that data, I typically do some loop admin. And then I'm going to return back to my loop here. Now if I run out of things to do here, what I'm going to do is restore context, and I should just return after that point. Okay, so that's my flowchart. It's pretty basic. Actually, the body of the loop here is this. This is really the only thing that happens in this program. And so yeah, so let's do this. So I'm going to switch over to the assembler and see how that goes. Okay, so we are back at the Venus assembler, and what we're going to do here is type out our solution rather than write it out by hand, simply because it just comes out a million times neater. And the idea is that you very rarely write code sitting on a piece of paper. Typically you write code by looking at a flowchart. So I don't have the flowchart here. We did that in the last part of this, but let's just start typing this thing. So we gave this a name. I think we called it transnum. Looking good. And I needed to save context. I know I need to do that somewhere. And then I don't really know what the context is because I don't know how many registers I'm going to use in this thing. And then I have some init code, which I don't know what that is. And then I have to do the body of the loop. Okay, so this loop, the initialization code, there isn't any because everything's sent to the subroutine. So the thing generally we do is initialize a loop count, or we initialize an accumulator. We have neither of those things, so we don't really have an init in this one. But I like leaving it in there anyway. So it is going to be a while loop because what we need to do here is check that condition first. That condition may be 0, so I'm going to check it. X11 is what was sent to me first, and if that X11 is 0 already, I'm going to say I'm done. Okay, so if you send 0, it's not going to do anything. Okay, so I'll say that as done. Okay, we can worry about that later. So there's my loop. Body of the loop is a matter of getting some data, and it was unsigned data, LBU, and I'm just going to put the data somewhere X I don't know, 25, look better than anything, and then the address of the data will say is 0, and that's the offset, and it was sent to me in a register which was X10. Okay, and that is get data. This is our while loop. Okay, get data. Once I get data, I need to store data. So I got it as a byte. I store it as a word, and that's going to be X25. That's where I got the data, so this is where I'm going to store it, and I'm going to store it at the address in X. Let me see what I put in there. X20 was where was the address we stored the data at. Okay, so this is store data. Okay, that's the entirety of my program. That's the meat of that's the body of the loop. After that, I have to do some admin, and so what I'm going to do here is adjust the loop counter, which is X11. So this is a decrement, and this is how many times I need to do this algorithm. What else do I need to do? I need to adjust the two addresses. So this is X10. X10 is bytes, and so I'm adding 1 to it every time. And this is advance the byte address. And lastly, I need to this is X20, which is the words. And what I'm going to do is advance that by 4 because it's words, and I need to give it 4 bytes of space each time through. So this is advanced. And at that point, I think I'm done. So jump, loop, and that looks good. Okay, so at that point, I just need to restore context, and I don't know what context I need to restore because I have to look at these registers. So I'm looking at this thing. I changed X11. I probably changed X25. X25 is going to change X10 and X20. So it's X11, 10, 11, 20, and 25. So I've changed 4 registers. So I have to save 4 registers on the stack. So that's 4 registers. So I have to adjust the stack pointer by 16 for 4 words, and that's going to be, what is that? Add immediate stack pointer minus 16. So that's going to give me enough space to store those words, and then I'm going to store them. Store 1 X10. This just take a second. 0 at SP. Okay, so that one. Save context, we'll say 4 registers. Okay, so I'm going to copy and paste this. This is why I do it online now. Okay, so X10, X11, I'm just saving all the registers I use in here. Ordering doesn't really matter because I'm going to cut and paste this on the end, and that's it. So there's saving of the context. Before I exit this thing, I need to restore context. and which is going to be down here. And I always, like I said, I like cutting and pasting this because I don't make errors on it. These are the registers in the other direction. I'm not saving them. I'm actually restoring them. That was wrong, of course. 0, 4, 8, and 12. So that means I'm storing 16 back, 12 back, 8 back, and 4 back. Okay, so once again, I went back 16 and I'm coming forward this many for the offsets on these. So this is going to be the same thing. 0, 4, 8, 12 looks good, and this is going to be positive 16. And so I think I'm done on this. I see there's a red line there. I'll worry about that in a second. Okay, it looks great. Everything's lined up. So save context. Save context is it's the same thing. It's the same label. Here's my restore context. And with that, okay, and I need a done here. And I'm going to say done label is choking. It wants to restore context. I like a done. I put a done label in there, so I don't lose anything by putting that done label in here. These are actually the value of done, and the value of restore count is the same thing, which is the address of this instruction here. So take one last look at this. Call it done. It is a subroutine. It needs a return. Certainly you can save some space there if you want. Yeah, I'm going to say this is done. See if it obviously assembles, so we'll call it done.